Hi everyone, it's Mr. Kwan here, and today we're going to talk about functions. A function is a relationship in which each input has exactly one associated output. Let's talk about an example. Tu and Khadija are both first-year college students at Highline. They are both wanting to start a snail mail group where everyone in the group sends letters to every other person in the group. At first, the group starts off small, only containing Tu and Khadija, so there is a total of 2 letters sent. Tu sends one to Khadija, and Khadija sends one to Tu. Later, Reina decides to join the snail mail group, and now there is a total of 6 letters being sent out. Reina sends a letter to Tu and Khadija, and Tu sends one to Khadija and Reina, etc. Let me just draw that so you have an idea of what's happening. So here's Reina, here's Tu, and here's Khadija. So Reina is going to send one to Khadija, Khadija sends one to Reina, Reina sends one to Tu, Tu sends one to Reina, Tu sends one to Khadija, and Khadija sends one to Tu. So if you count the arrows there are 6 of them, and that's where that number is coming from. So let's say a now 4th person decides to join the group. So maybe Mr. Kwan here, he likes to write letters, and so he ends up joining the group. So Mr. Kwan would send one to Tu, Tu would send one to Mr. Kwan would send one to Khadija, Khadija would send one to Mr. Kwan, Reina would send one to Mr. Kwan would send one to Reina, Tu would send one to Khadija, and Khadija would send one to Tu. Now, that's a lot of arrows, so let's count them. There's 2, 4, 6, 8, 10, 12. If I decided to add in a 5th person, if I'm going to make a drawing like that, that's going to be a lot of arrows to draw. And so mathematics a lot of times is about patterns. So part B asks, do you see a pattern? Can you come up with a general rule for figuring out the number of letters being sent for any number of people? Do you think that this represents a function? So, it's not too bad to do it for these smaller numbers, but what if we eventually wanted to figure out how many letters would be sent if our group reached 100 people? Drawing these pictures is going to be very time consuming. So what is the pattern here? Well, we see that if there are 4 people in the group, then every person is sending the amount of letters that's equal to 1 less than who's in the group. Like, for example, Mr. Kwan is sending out 3 letters, Khadija is sending out 3 letters, Reina is sending out 3 letters, and Tu is sending out 3 letters because you're sending a letter to everyone that is not yourself. And so we can actually make this into a multiplication statement. Notice that it's equal to the number of people in the group times 1 less than everyone in the group. And that pattern holds true for these other ones as well. So if that pattern were to hold true, then for 5 people in the group, it would be 5 times 4, which is equal to 20. And I drew out the picture on another day, and I'll let you know and verify that it does check out. So for 100 people, it would be 100 times 99, which would be 9,900 letters. That's a lot. So let's write the pattern. So the number of letters sent is equal to the number of people in group, and we're going to multiply that by 1 less than number of people in group. And that's the pattern. Now, the second part of this question asks, do you think this represents a function? And the answer is yes, because for any input value, the input value here is represented by the number of people in the group. There's only going to be one amount of letters to send, not multiple amounts. So it's always going to be whatever this number is here. And so we say, yes, this is a function. Because for any number of people in the group, there will be exactly one amount of letters sent. All right. So there's this thing in math called the vertical line test, and it's really nice because it tells us if a graph represents a function. And functions have many representations. You can see them in an equation, in a table, or in a graph. But for the graph part, the vertical line tells us whether it's a function or not. And so the vertical line test says that if you're looking at a graph and can draw any vertical line that intersects or crosses two different points on the graph, then it is not a function. Otherwise, the graph does represent a function. So let's look at some examples of that. The example 2 says, look at the graphs below and determine whether or not they are a function. If they are a function, state the domain and range. So I'm going to draw a vertical line here on this circle graph, and notice that it does not pass the vertical line test because my green vertical line, intersects or crosses the circle at two different places. So we can say not a function, does not pass the vertical line test. All right, let's move on to the next one. So I'm going to draw a lot of vertical lines. So I'm going to draw one there, one there, one there, one there, one there. Try to pretend that they're straight because I'm struggling with that. But assuming these are straight vertical lines, notice that every circled spot, it's only intersecting the graph one time. And so for any vertical line that I draw, that's going to be the case. There's only going to be one intersection point. And so this is a function because it passes the vertical line test. Now, that means that we want to talk about the domain and range. So let's start off with the domain. Remember, the domain represents the x values. And so if we looked at the x-axis, which is what I'm highlighting right now, notice that the graph has these little arrows right here, which indicates that it's going to go on forever in both the left and right directions. And because it's continuous, which means that if I'm drawing the graph, I don't lift up my pen or pencil, that means that the domain is going to be everything. And so if we're going to write that in interval notation, it's going to look like this. Negative infinity to positive infinity, like that. Okay, and then, so that's an interval notation. And then if we're talking about the range, then that's going to be the y values. So let me highlight the y-axis. Notice that the graph doesn't go below a certain point. So unlike the domain, our range is not going to be everything. Notice it stops here at this point, and the y value is -2 there. So, and because our graph contains that point, we're going to use a bracket. So it's going to be -2, and then it goes up from there to positive infinity, like that, and we're going to put parentheses there. Okay, so that is the range, and your homework might ask you to represent that in inequality notation instead of interval notation. And so inequality notation looks like this. The range is the y values, so we say y is greater than or equal to -2. Okay, so these are our final answers. All right, let's see if this graph passes the vertical line test. So The only point that we're probably concerned about, notice that these intersect only once, is probably right here on the y-axis. Now you might be asking yourself, is that intersecting at two different points? The answer is no, because notice here there is an open circle, and here there is a closed circle. The open circle means that that point is not on the graph. So this does pass the vertical line test, and it is a function. So let's now talk about the domain and range. So the domain is the x values, so from there to there. Oops, sorry. From there to there. Now notice the endpoints have open circles, so that means that those points are not contained on our graph, and so that means that we're going to need to use parentheses. So our left endpoint there is -3, and then our right endpoint is +2. And if I wanted to write that in inequality notation, that would look like x is greater than -3 and less than 2. So that's how you would write it in inequality notation. Now let's talk about the range. So the range is the y values. The highest point is like right there, and then the lowest point is right there. And notice that if we were to write this in interval notation, it ranges from 0 to +5, but on 0, there's a closed dot right here, and so we're going to end up putting a bracket. And then for 5, we're going to put a parenthesis since that's an open circle right there. And for inequality notation, that's going to be y is greater than or equal to 0 and less than 5. So there is our final answer for that one.